So implicit differentiation really just involves an application of the chain rule. So it's not a new technique. It's just going to be a technique we use to analyze different types of functions than you're necessarily used to. All right, so this first slide has a ton of writing on it. It's pretty verbose. You don't need to write any of it down. It's just going to help me kind of introduce the idea. So, oh, not this slide. That's not too much writing. We have functions like these in which we call them implicit functions. And they're a little different than what are called explicit functions, which are y is explicitly written as a function of x, right? So that would be like y equals x squared. Y is isolated, and there are x's on the other side of the equal sign. In this case, x and y are kind of intermingling. Do you guys know what this is an equation of? Do you recognize this equation? And if so, can you throw it in the chat? Yeah, good. It's a circle, right? So a circle isn't a function of x because it doesn't pass the vertical line test, right? But I could solve for y in this case pretty easily. We just subtract over the x squared. And then we could take the square root of both sides, but what we would end up with is actually two equations. We'd have the positive square root, and then we'd have y equals the negative square root of 25 minus x squared. And all that does is break our circle up into two halves. We'd have the top half, right, the positive square root, and we'd have the bottom half, the negative square root. And that way, if I wanted to if I wanted to analyze it using calculus, right, like find a tangent to the curve at a certain point or whatever, I could just do it using either the top piece or the bottom piece and have no problem. But what about functions like this? If I tried to solve this one explicitly in terms of y, I'm going to run into some issues because I have a y here as well. And so, in fact, it's possible, but it's nearly impossible to do by hand. You would have to use a computer algebra system. So basically use a computer to solve it explicitly in terms of y, and you'd get three equations instead of the two like we got with the circle. But what if I wanted to still do calculus and analyze this curve? How would I do that? And so that's what we use implicit differentiation for. So we are going to look at the graph of that curve. It's cool. It's like a little loop-de-loop. It's called the folium of Descartes. But we'll talk about that in a moment. All right, so what is implicit differentiation and how do you do it? I'm going to give you just a series of steps. And these I do want you to write down. So, all right, so implicit. Okay. Differentiation. Okay, the first thing you're going to do is replace y with f of x. Step 2 is differentiate. So what I mean by that is do dx So you're going to differentiate both sides of the equation with respect to x. Then you're going to go back in, you're going to replace f of x with y. Then you are going to solve for y prime. All right. Give me a green check when you're good with that slide. Okay. So here's the folium of Descartes that I was talking about. We're going to analyze that in a moment. If you have a computer algebra, actually explicitly solve that equation for y. Like we did with the circle, right? We solved for y and we got the top half and the bottom half. Here's what it looks like. Yo, come on. Sorry, is my computer lagging? I'm looking at my iPad. All right. Here's what it looks like in 3 separate pieces. All right. So we're just going to jump into an example. We're going to work with that circle that had the radius of 5, right? Because this is the general, remember the general equation of a circle is x squared plus y squared equals r squared. Except we're going to deal with it implicitly now. We're not going to solve explicitly in terms of y, which is what we did in the warm-up. We're going to use implicit differentiation to find the derivative. So they're asking us basically find y prime, right? So here we'll go. Step 1 that we wrote down, we're just going to replace y with f of x. So I'm going to go x squared plus, instead of y, f of x squared equals 25. And the idea with doing that is we're assuming it is possible to write y as a function of x. Like it is possible to solve explicitly in terms of y. So y is assumed to be a function of x. All right, so step 2, we're going to differentiate both sides with respect to x. So take the derivative of everything on both sides. All right, well, the first piece is no problem, right? Derivative of x squared would just be 2x plus, but what rule in the chat do I need to use to differentiate this? Yeah, excellent. So chain rule, right? So derivative of the outside first would be bring down the 2. You're going to have just leave f of x as is. It's technically to the first power. We don't have to write an exponent of 1. Times what? What would I call the derivative of the inside function there? What should I call the derivative of that? Good. So we're just going to write times f prime of x. Excellent. So as you can see, it's just the chain rule. And then what's the derivative of 25? What's the derivative of any constant for that matter? 0. Got it. All right. Next step, let's replace f of x with y. So I'll have 2x plus 2y times y prime equals 0. And then last, we'll just solve for y prime. We just want to isolate y prime. So 2y times y prime equals negative 2x. Y prime equals negative 2x over 2y. Y prime equals negative x over y. And that's it. And it's okay for our answer to be in terms of both x and y because our original function was in terms of x and y. It was an implicitly defined function. So we're going to expect that our derivative will also be implicitly defined. And all it says basically, right, is on this circle, if you want to find the slope of the circle at a given point, take the x coordinate, divide it by the y coordinate, and negate it. So let's say we want the equation of the tangent line at the point 3, 4. Well, y prime at that point 3, 4, the slope at that point 3, 4 is just going to be negative 3/4, right? So the equation would then be y minus 4 equals negative 3/4 times x minus 3. Okay. And I just real quick want to check our answer. Let's go over to the old Desmos calculator. And our circle is x squared plus y squared equals 25. Okay. So now I have y minus 4. Oh no, let's graph. So, sorry, the point is 3, 4. And the tangent is y minus 4 equals negative 3/4 times x minus 3. There we go.